Hi students, see today we are going to discuss about the coordination chemistry. Already we've seen in class 11 the chemical bonding. The chemical bonding lesson, so many connections are there. That is, so many connections mean the hybridization, then VBT, so many things are there. We are going to learn here that advanced level that is called coordination chemistry. See, in this coordination chemistry mainly contains the Werner theory. What is that Werner theory? The Werner theory mainly discuss about the primary valency and the secondary valency. So that theory we are going to discuss. Then the important terms in the coordination chemistry. What is that important terms in the coordination chemistry means? Coordination entity, coordination sphere, coordination number, then homoleptic and heteroleptic complexes, oxidation state, so ligands, so many things are there. That is important terms in the coordination chemistry. After that we are going to discuss the nomenclatures of the coordination compounds. What are the nomenclatures of the coordination compounds mean? Already we seen the IUPAC names in the organic chemistry, that is in class 11. In this year you are going to learn both organic and the inorganic. Here the inorganic compounds are, that is simply we are called complex. They that complex we can name it. So the complex is cationic complex, anionic complex and non-ionic or neutral complex. How to name it? So that that is also we are going to discuss. After that, the bonding in coordination chemistry. What are the bonding in coordination chemistry mean? Valence bond theory. We are going to discuss the valence bond theory and the crystal field theory, ligand field theory, molecular orbital theory. In this year, you are going to learn only the valence bond theory and the crystal field theory, and also hybridization. Then type of hybridization already you were studied in class 11 also. Yeah, here also again you are going to read. Then next is application. Application, colored complex, stability of the coordination complex, then electronic configuration, writing the electronic configuration of the coordination chemistry, then calculations of magnetic moments and crystal field stabilization energy. So these things are we are going to discuss. Now we'll start the lesson, the coordination chemistry. Hi students, today we are going to discuss about the coordination chemistry. Already we seen in class 11 the chemical bonding. This is the connecting lesson. The coordination chemistry is the connecting lesson. The coordination chemistry mainly discuss about the Alfred Werner's theory. The Werner theory concept is valence in inorganic chemistry. What are that? Valence. That is the well-known concept, primary and the secondary valencies of metal complexes. See, here the Werner Cobalt complexes, these are the Werner Cobalt complexes. The COCl3.6NH3, the number of chloride ions precipitate as silver chloride is 3 and the formula will be CONH3 6 times and Cl3. There is a number of ions in solution 4 and color of the complex is yellow. Then the COCl3.5NH3, the number of chloride ions precipitate as silver chloride is 2. Then formula of the compound is, the complex is CONH3 5Cl and Cl2. The number of ions in solution is 3. Then color of the complex is purple. Look at this. The COCl3 4.4NH3, number of chloride ions precipitate in silver chloride is 1 and the formula is CONH3 4 times Cl2 Cl. The number of ions in solution is 2 and the color of the complex is green. Then look at this fourth complex, COCl3.4NH3. Here also the same. Look at this third and fourth. The molecular formulas are same, but the properties like the color is changed. One is green, another one is violet. In this complex is called isomerisms. So, isomerisms of the coordination complexes. Now, we will see the postulates of the Werner theory. The postulates of Werner theory, mainly the primary valency is ionizable and the secondary valencies are non-ionizable. See, look at this complex. Here, which is a primary valence ion, the secondary valency compound. Look at this. In this, the chloride ion, there is a CO, NH3, 6 times Cl3. So, this is the metal. I wrote here metal here, and metal surrounded by the 6 ligands and the chloride ion. See, this is the dotted line, that is the primary valency. The primary valency is ionizable. This is the chloride ion. Then the solid line, this are called secondary valency. See, the primary valency can satisfy negative ions and the secondary valency can satisfy by anions or neutral molecule. Then the secondary valency are directed towards some fixed positions, okay, directed towards some fixed position in the space. For example, the 4 coordination complex for 4 valence are arranged in the square planar or in a tetrahedral manner. Then 6 coordination complexes are, 6 valences are directed in the towards in the 6 corners like this. So, these are the octahedral arrangements. Okay. Next, we will see the double salt. What is the double salt and what is the complex salt? See, the differences of the double salt and the complex salt. So, the double salt contain 2 salts in the equimolar ratio. Then the complex salt contains ions may or may not be equimolar ratio. That is complex salt. So, they contain equimolar ratio and they may be or may not be contained equimolar ratio, and the double salt only exists in solid state. They exist only in solid state. In this complex salt, they exist solid as well as aqueous in aqueous state. Solid and aqueous. Then the double salt usually forms a simple ions in aqueous solution. Example, potassium K plus, Al 3 plus, like this, SO4 2 minus. So, they are forms like that. The forms a simple ions. In complex salt, they forms a complex ions in aqueous solution. For example, FeCN 6 times 3 minus, sorry, 4 minus, 3 minus or 4 minus, like this. See, the important terms in coordination chemistry. What are the important terms? We are using the coordination entity, central metal atom or central metal ion, ligands. Ligands are classified monodentate, didentate, polydentate. Then the coordination number, then coordination sphere, oxidation state. The last one is homoleptic and the heteroleptic complexes. First, we will see the coordination entity. What is that coordination entity? The metal ion and the ligands immediately attached to it, the called coordination entity. For example, we can write that as FeCN 6 times 4 minus. So, this is simply we can tell that is coordination entity. Then the central metal ion or the central metal atom. See, here in a coordination complex, one metal is present. So this is called metal ions. So this metal ions are called central metal atom or the central metal ion. Then ligands. What are ligands? Ligands is a donor atom. Okay, ligands is a donor atom. It is a monodentate ligand, didentate ligand, and the polydentate ligands are available. See, the monodentate ligands, that is simply we can tell that is I minus, example, chloride, bromide, iodide. So simply we can tell like that, that is the monodentate ligands. Then the polydentate ligands is cyanide, SCN minus, SO4, 2 minus, NO3 minus. So these are polydentate ligands. Okay. Then the didentate. The didentate ligand is ethane 1,2 diamine and oxalate ion. So C2O4 2 minus. Simply we can write En for ethane 1,2 diamine. So these are called didentate ligands. Then the coordination number. What is that coordination number? The coordination numbers mainly in a complex, the number of ligands present in the complex, that is total number of ligands are present in the complex. For example, I will write here CO NH3 4 times and Cl2. See, in this complex, the number of ligands is what? 2 ligands are present. So the 2 ligands having, this is 4 and this is 2. So in this complex, the coordination number will be 6. Similarly, we can write it CO Cn 4 times or Fe Cn 4 times 4 minus mean, see here the coordination number is 4 because only 1 ligands are present. So the total number of ligand is 4. So this is called coordination number. Then the coordination sphere. In a coordination chemistry, usually the complexes are always written in a square bracket. So simply we can write, we can tell this is complex. We can name it this complex, that we will see later. Simply you have to write the coordination complex in a square bracket. They are called coordination sphere. Then oxidation state. What is that oxidation state? Here metal having one oxidation state. So you can find the oxidation state of the central metal ion, then helpful to predict the shape of the elements, that is the shape of the complex, whatever it is, we can discuss later. So this having one oxidation number, they are called oxidation state. For example, we can find in this metal ion oxidation state. So CO NH3 4 times, or we can write 6 times, and Cl3 like this. Here, what is the oxidation state of the CO metal ion? We don't know, that is why just put X. This is a neutral ligand, so the neutral ligand having 0, and this chloride having -1 charge. This -1 means -1 into 3, sorry, -1 into 3 minus 3, it will become -3. So X is equal to X plus 0 is equal to it will become X is equal to plus 3. How it is possible? Or you can write it, that is, this will be plus 3 means this should be, this is -3 means this should be plus 3. See, the complex charge and the metal complex ion charge should be equal. So here plus 3 means the metal ion should be plus 3. So X is equal to plus 3. This is the finding the oxidation state. Then the homolytic and the heterolytic complexes. What is that homolytic and the heterolytic concept? See, the homolytic complexes are metal is bound to only one kind of ligand. For example, this we can take, we can say that is, this is the homolytic complexes, and that is one kind of the donor atom is present here. Here look at this complex, this having two different kind of ligands are present. So they are called heterolytic complexes. More than two is heterolytic complexes, more than two kinds of ligands are present mean heterolytic complexes. Only one kind of donor atom, that is ligands are means they are called homolytic complexes. See, already we seen that ligands, what is the ligands are donor atom. Here the ligands are positive ligands, negative ligands, and neutral or non-ionic ligands are available. The positive ligands are very rare. They are end with IUM, that is called hydrazinium, hydronium, nitrosonium, like this. So positive ligands are very rare. Then the negative and the non-ionic or the neutral ligands are very common. See, the negative ligands are end with O, that is symbol is O, that's called chlorido, bromido, iodido, cyanido, oxalato, sulfato, nitrito, like this, end with O. Then the neutral ligands are amine, NH3 is amine, H2O is aqua, NO, nitrosyl, EN, ethylene diamine, that is ethane 1,2 diamine, carbonyl, pyridyl, so like this. So these are called non-ionic or neutral ligand. Now we will see the coordination complex, that is how to name the coordination complex, that is called nomenclatures.